All right, so let's go over number 2.6. This is a classic calculus problem. That's kind of why you're doing it here. Well, it's a good problem anyway. But in calculus, you can figure out the fastest way to solve this problem. What is the fastest place to go depending on how fast you paddle and how fast you walk? In this problem, we'll just kind of find out that going somewhere in the middle is the fastest thing to do. So here's the idea. So Brooke is 5 miles out in the water. She paddles her boat at 2 miles an hour, pretty slow, right? But she can walk at 4 miles per hour. So what is the fastest way to get to Konos? Now going straight there is not the fastest because she only goes 2 miles an hour. That's the shortest distance, but she goes really slow. Somewhere in between, going somewhere like this is fastest depending on her walking and paddling speeds. If she paddles really, really fast, then probably more like this is good. If she paddles really slow, more like this is good. It's never best to go straight there if you paddle slower. And it's never best to go straight here, even if you walk really fast. It's always going to be something in the middle. So part A says find a formula for the time it takes if you do something in the middle. So for instance, if you follow this line here, I'll make it in green or something. So they made a dash line there. So if you go like this, what is the time it takes? And first, you need to set up a coordinate system. Typically, it's always nice to make everything positive. So it makes sense to set up the axes like this. So our x and y axis like that. Okay, so that just makes sense where A is the origin. And so this point here that you land is x. So this distance here then, that distance you go there is x. Okay, that means that this distance here from that point to there is going to be, let's see, it is, how far is Kono? 6 miles? So that distance there is going to be 6 miles minus that. So this is 6 minus x. Okay, putting on a coordinate system and labeling things is really important. Drawing this picture, you can't do this without drawing the picture. If you printed out these pages, maybe you could write on top of it on the paper. It's just not that hard to draw the picture. Those of you who try to cram all your work in little tiny spaces, it's going to take you longer. It's way faster, way better. You're more likely to get things right if you spread out, draw big pictures. I always draw pictures too small. You know, I cheated here. I put this one up here and I made it bigger, and I probably should have even made it bigger. I should have zoomed in even more because you start writing things like this and it starts getting all cramped. Always make your pictures really big. Use lots of paper. You know, use scratch paper if you have to. I always use the back sides of printer paper and stuff where one side's been used. You know, so don't waste paper, but spread out, draw big pictures. You'll get it right way more often. Yeah. Okay, now we need to express, we want to know how long this green line is here. All these problems are going to be like Pythagorean theorem problems. So if we know this is 5 miles, and we know this is x here, right, this distance here is x, then we can figure out this, right? So this is the square root of this squared plus that squared. So this distance here is the square root of 5 squared plus x squared, which we can just write that's square root of 25 plus x squared. Might as well square out the 5. The x squared will leave like that. So the total distance that this person goes is this distance plus this distance. Okay? But the time it takes, this distance she's going 2 miles an hour, and this distance she's going 4 miles an hour. So the total time, I'll do that over here, the total time t, which is, time is always distance divided by velocity. How long it takes you depends on how far you go divided by how fast you go. We have 2 parts to that. First, there's this distance, which is this, square root of 25 plus x squared divided by the velocity for that part is 2, and everything's in miles and hours. We got to make sure that, or miles per hour and stuff. And so then plus this distance, which is 6 minus x divided by 4. So plus 6 minus x divided by 4. That's the total time it takes to get there. Yeah. Okay, so this expression here is how long it takes to get there, and I think that's the one that they get in the back of the book. 1/4. Yep, 1/2. They put a 1/2 and 1/4, which is the same thing as dividing by 2, dividing by 4. Okay, so that's part A. Just saying the total time is 2 parts, depending on how fast you go. Now, for the other ones, they're just saying, okay, how fast does it take if you go, how long does it take if you go straight to there? If you go straight to there, x is 0. We can use our formula, just make x 0. We can make that point anywhere we want, from 0 to x equals 6. So for part B, we can just use this formula and say x is 0 here, because we're going straight to here. If x is 0, this is the total time then is the square root of 25 divided by 2 plus 6 divided by 4. And we can get a number for that. And then part C, the total time. Now they say, well, what if you go straight to here? Sorry. If you go straight to here, then x equals 6. I think that's right. So part C says, determine the total time to reach Konos, directly to Konos. So if you go to here, then x is equal to 6, right? X is the point she lands all the way to 6. So you do the same thing. So then t is square root of 25 plus 6 squared divided by 2 plus, this is 0, right? 6 minus 6, 6 minus 6 divided by 4, that's 0. And you can figure out what that number is. I'll let you guys do that, how long it takes if you go straight there. And they have the answers that they got. Now, they're saying, which one is faster? Going straight there or going straight to shore, right? Which way is things faster? Just minimizing the paddling time, getting the paddling over with and walking fast, or going straight there, all paddling. And I believe they say if you do the math, you should get that when x is equal to 0, you get 4, and then when x is 6, you get 3.9. So they say you get about 4 here. They call this t of 0, the time when x is equal to 0, and this is the time when x equals 6. That's what that means there, t when x equals 0, t and x equals 6. I think they got this one slightly faster. You can do the math, 3.9 hours or something. Now, that's D, so then I guess this one's faster. Now E says, what if you go halfway in between? Is that even faster? And is that the fastest? Well, you kind of got to do a guess and check to find the fastest. But let's try halfway in between. Halfway in between, x is equal to 3. So plug in x equals 3. So the way they would write it was t at 3, right? So yeah, 6 miles, so halfway is x equals 3. T at 3, you plug in here into our formula, square root of 25 plus, that looks like the times, 25 plus 3 squared divided by 2 plus 6 minus 3 divided by 4. I'll let you figure that one out, finish up that math. I believe that probably that's faster. You'll find it's even faster to go halfway in between. And the real question is, where is the fastest place? And it all depends on these numbers, the two, how fast you paddle, and how fast you can walk. It's going to vary, but probably somewhere, maybe that's the fastest halfway in between, I don't know. Maybe somewhere else is the fastest, but that's the idea. And again, this is a classic calculus problem. So it's kind of fun to think about. It's a real problem if you're swimming, right? If you want to get over here, do you swim straight here? Do you swim straight there? Probably somewhere in between, depending on how fast you swim and how fast you walk. All right, hope that makes sense.